This is Supplementary Problem 27 in Module 2 from the book Problem Solving Guide for Mechanics and Thermodynamics. A baseball pitcher is challenged to throw a baseball over the physics department while standing 10 meters away from it. It's a building that's 22 meters high, 20 meters wide. He releases the ball 2 meters above the ground, so the vertical displacement of the ball needed to clear the top edge of the building is 20 meters. What is the minimum speed with which the pitcher can throw the ball to just make it over the building? Give your answer in units of miles per hour to 2 significant digits. Well, let's start with a good diagram. Here's the physics department building. It's 20 meters wide. The baseball pitcher is standing 10 meters away from the building, and he's going to release the ball 2 meters above the ground, and it has to go 20 meters more to clear the building, so that distance is 20 meters. So now we have to think. What's going on here? Minimum speed to just make it over the entire building. If it's going to be thrown at the minimum speed, it seems like it's got to just miss this edge and just miss this edge. So let's put that in there. Let's put the trajectory of the ball in there. Something like that. Okay, gravity's pulling it down the whole time, accelerating it downward at 10 meters per second every second. What now? Well, let's define a time. The time it takes to the front edge, let's call that t sub edge. So now we can do some physics. We can write an equation. In the vertical direction, we have y is 1/2 a sub y t squared plus v initial y t. Y is plus 20 meters. It goes up 20 meters. Gravity is 10 meters per second squared down. We don't know the time. We're defined it as t sub edge, and we don't know the initial speed in the y direction, so we have 2 unknowns and 1 equation. We need another equation. If the ball is going to just miss the front edge and just miss the back edge, it has to be at the peak in the middle. So we know the ball is at its peak after it travels 20 meters in the horizontal direction, right in the middle of the building. The building's 20 meters wide, halfway is 10 meters. The pitcher is 10 meters away. So after traveling 20 meters horizontally, the ball is at its peak. The time it takes for the ball to travel 20 meters horizontally is twice the distance it takes to travel 10 meters horizontally, because the speed in the x direction does not change. So the time it takes to get to the peak is 2 t sub edge. Now we know gravity takes away 10 meters per second every second. So we can write an expression between the time the ball is in the air and the acceleration due to gravity and the initial speed. Initial speed in the y direction is 10 meters per second every second times the time, 2 t sub edge. V final sub y is 0. It's at its peak. We can substitute this expression back into our expression for the distance in the y direction. And here's the equation, 20 meters minus acceleration, and here in square brackets is v initial y. We got this by knowing it's at the peak at 2 t sub edge. So now we just do some math. We have one equation, one unknown. We combine the terms. Half times minus 10 is minus 5. 10 times 2 is plus 20. We have plus 15 meters per second squared times t sub edge squared. That's 20 meters. We can solve for t sub edge. Taking the square root, we get 1.155 seconds to get here. From this, we can get v sub I x and v sub I y. V sub I y is 10 meters per second squared times 2 t sub edge. That's 23.09 meters per second. That's the initial vertical component. Initial horizontal component, it takes 10 meters. It takes t edge to go 10 meters. So that's 8.66 meters per second, because that's t edge. Now we can use the Pythagorean theorem to get the x and the y components. There's the x, there's the y. Square them, take the square root. We get 24.66 meters per second. But to get full credit, we have to change this to miles per hour. So we did that, and we get 55 miles per hour. That's problem 227.